So we have KVL, which is Kirchhoff's voltage law in this new problem. It's got quite a few elements. Let's start drawing the circuit diagram. So we have one element on the top, another one here, and another one here. Okay, another element here, one element here, and down below we have another element here. Quite a few of them. 1, 2, 3, 4, 5, 6. So the given info is there's a voltage drop of 5 volt across this element. And here is plus minus 10 volt. This one has plus and minus 15 volt. The task is to determine voltage across the top element. It's called V sub C. V sub C, okay? So that has to be determined. Another one is here, plus minus V sub A. That has to be found. And plus minus V sub B. That has to be found. So the task here is to determine V sub A, V sub B, and V sub C. So what we have is several elements in the circuit. Some of the voltage drops are given, some of them are not. We will use KVL, which is Kirchhoff's voltage law, in each of these meshes. Like this is mesh number 1, mesh number 2, and mesh number 3 here on the top. So let's get started with mesh number 1 and apply KVL. So KVL in mesh 1. So we have to start counting the voltages along the path. So if we start at the bottom of this element, somewhere here, so what we say is minus 5 as we go along the travel along the path, we encounter plus VA, then plus 10. Okay, so that should balance. Now this 10 is right here on the top. So it's a 10. Okay, already. So that will mean V sub A. So this is giving us V sub A equals minus 5 volt. So this is giving us this result. What else? Likewise, if we use KVL in mesh number 2, so that will give us minus 10. We start here, minus 10, and then plus 15 plus V sub B equals 0. So that will mean V sub B is minus 5. So we got another result here. V sub B is minus 5. Finally, KVL in mesh number 3 implies minus VA plus BC and then minus 15 equals 0. But V sub A is known to be minus 5, so minus V sub A is minus times minus plus 5, and then plus V sub C minus 15 equals equals 0. So that will mean P sub C is 10. So P sub C is 10 volt. So that is the result of this last calculation. Okay. So what do we do now? We will check if all these numbers make sense or not. So the best way to examine these numbers is to redraw the circuit. So let's redraw the circuit. So as we do that, we do not need to write P sub A, P sub B, P sub C because those are known quantities. And keeping in view of the negative polarity, with P sub A and P sub B, we will have to transpose the plus to minus and vice versa. So plus P sub B on the right end would mean our minus better be here and plus here 5 volt, and this one is already 10 as given. Okay, hey. So plus minus 15, hey, plus minus 5, that's already given. And we found P sub A is minus 5, meaning we will have to swap this minus and plus, and pi b will stay here. So at the top is plus and minus 10 volt. Now in this case, we have all the voltages in numerical form. So now if we go through all the meshes, we can see whether they make sense or not. For example, if we stay with, let's go around mesh number 1, and then we'll go up here, it's up to us, and then we might go maybe here all the way, okay, or any which place, as long as we have a closed path, it should balance. Here in this path, we have minus 5, we have plus 10, and we have minus 5. So the question is, does it give 0? Of course it does. So we can figure out in any form, we can see easily minus 5, okay, minus 5 plus 10, of course equals 0. This is along mesh number 1. If we go along mesh number 2, we have minus 10 plus 15 minus 5. Yes, that's also equals 0. So we can check in various forms and manners if we pick up any closed path, as long as it's a closed path, starting point and the ending point being the same, and if we keep on adding, shall I say, keeping in view of the polarity, we keep on adding the voltages, they all satisfy Kirchhoff's voltage law. All the little pieces seem to make perfect sense in the big picture, and that's pretty nice. Hope you enjoyed it. See you later. Take care.